Hello friends, this is lesson 16 and here we are going to talk about types of supervised machine learning. So in last lecture we talked about machine learning and we said machine learning is divided into three types. We have supervised, unsupervised and reinforcement. But in this lecture we are going to talk about supervised machine learning and we are going to cover these topics here. First we are going to talk about regression models, then types of regression, like we have simple linear regression, we have multiple linear regressions, and then we will talk about dummy variables, regression matrix we are going to talk about, and then we will talk about regression matrix which are used for feature selection, and we will give some examples for them. And let's start it now, friends. So let's see, what are regression models? This is a question. What are regression models? So regression models, very simple definition here, friends. Regression models attempt to predict continuous responses. So we provide the model the data, which is called the input, or we say the predictors or the features for the system. So the output of the output or predicted output is nothing but it is continuous values. It will be in the form of continuous values. It is not like in the form of discrete values like 1, 2, 3, or maybe like binary form, true and false, or maybe like we can say yes and no, correct and correct, wrong and correct. Not like that. It is in the form of continuous values. So if the predicted or the output value is continuous, so that type of models are called regression models. So these models are nothing but they attempt to predict continuous responses. For example, here we have, if the output is nothing but the salary, we have to predict the salary of employees, or maybe we are predicting the height of people, the weight of people. These are nothing but continuous values or continuous responses. So if this is the case, so these models are called regression models. For example, if you are predicting the salary of employees, we have to provide some data for the machine, or we can say for the model, maybe like qualification of the person, maybe seniority, or we can say work experience of the person, or maybe some other features, and based on that the model should predict the salary of employee. So salary of employee is nothing but it is a continuous value. So if it is in continuous value, so it is nothing but regression model. We need regression model to attempt and predict the continuous responses. So that is why we are using regression models. In that case, if we have continuous responses, this point you have to remember, continuous responses, or we can say continuous output, outcome, whatever you say. So if the result is continuous values, so that in that case we need the regression models. So let's see the types here. The first type of regression model is simple regression model. Simple means what? Here we have only two variables. One is called dependent and another one is called independent variable. Here y is dependent variable because it depends on the value of x. Whatever we give the value of x, that will be multiplied with this coefficient of x. And here we have b naught, which is called the y-intercept. So these values are all calculated, the expression, and the result is stored in y. So y is dependent value and x is independent value. So it finds the relationship between two variables. Here we have, for example, if we are predicting the salary of an employee based on his working experience. So working experience is the only feature. So for example, if we have 3 years, 4 years, 5 years, we have to put it here, and those values are all multiplied and added, and the result will be predicted. If person has 5 years experience, 3 years experience, the model will predict the salary of that person. Maybe the relationship is positive. For example, if x is increasing, the value of y is also increasing. If x is decreasing, the value of y also decreases, so the relationship will be negative. If there is no relationship between, for example, if this is 0, so y will remain constant like that, so that is called no relationship or no correlation. Now here the name itself suggests multiple linear regressions. It means here we have multiple independent variables, not a single. Like here we have only single independent variable, but here we have multiple independent variables. Like here we have x1, here we have x2, x3, x4. It means now we are predicting the salary of person based on more features, not a single feature but multiple features. Here maybe like we are considering working experience, qualification of the person, maybe some other like discipline, some other features also, and based on all those features the salary of the person will be calculated. So it means the relationship between one dependent, which is y here, and multiple independent variables, so that is nothing but multiple linear regression. So here also the output will be in the form of continuous response. You have to remember, here also we have continuous response, here also we have continuous response. So that is why it's called regression, linear regression model, and you have to understand that. The next thing you have to know, friends, about it is dummy variables. Why does dummy variables are required here, or what is the usage of these dummy variables? Dummy variables used when we are hoping to convert a categorical, or we can say ordinal features into quantitative ones. You know that machine or models are working with numbers or quantitative values, but if we have categorical data, so categorical data like male and female, so that cannot be calculated, or that cannot be like it is not in the form of numbers, so the machine cannot do or calculate on those numbers. So those numbers should be converted to some those values should be converted to some quantitative values, and then the machine can do or apply some statistics or probabilities on that and calculate some values and then predict the response value. So it has to be converted from categorical into some quantitative ones. For example, ordinal numbers, we said, if you remember the features, and their categorical data again was classified into two types. If you remember, we have nominal and ordinal. In nominal, like we had, the order was not important. If you remember, friends, like male and female, order was not important. But sometimes when, for example, if we consider qualification, in qualification we give them order, like PhD, the person who is holding PhD degree, so we are giving them 3, and for master 2, for bachelor 1. So if you are assigning this values, so it becomes ordinal and it is converted to quantitative ones. Now the system can apply statistics and probabilities on those values and predict the response values. So it is required for converting categorical data or features into quantitative ones. So now let's see regression metrics. What metrics we have here to calculate? So in regression, we don't have to go for model classification. This you have to remember, friends. Here we don't go for model classification accuracy to calculate what is accuracy of the model. Instead, here in regression models, we are going in calculating some types of errors. So these types of errors we have to calculate. Here we are not going to calculate the accuracy of the model, like what is the accuracy of model, the percentage, the higher accuracy, so that model is preferable. So if the model has lower accuracy, so that model will be neglected. So instead of that, we are not going to classification accuracy. Instead, we have to calculate different types of errors in regression models. So the first type of error, which is called, this one, mean absolute error, and it is nothing but the average error. So we have to find the average of the error, and that will be called as okay, mean absolute error, and the second one is called mean squared error, and root mean squared error we have to calculate. And one thing you have to remember, minimum error rate is preferable. So we have to minimize how much we can do, minimize the number of errors or the rate of error, so that model will be preferable. The maximum error if the model has, so that is not preferable. So we have to reduce the number of errors or the rate of error in the model, and that is based on removing some features, maybe the features on unrelated features, so we have to remove those features, and we have to add some features which has like a closed correlation with each other. So by adding those features, so the number of errors will be reduced, and removing some unrelated data or noisy data, some which has okay, less correlation or weak correlation. So those features if you are removing, so the relationship becomes closed and the number of errors are reduced, so that model will be preferable there. And here one thing else you have to remember, friends, regression models or regression matrix, what we said, they are helping us in feature selection. So how they are helping us? So regression matrix, like these errors what we are calculating, so through these errors we can select the features by adding and removing, as I described earlier. So by adding and removing the features and check for the minimum error, so then we say these features are required, or we have to select those features, or those features which has like more number of errors, we have to neglect those features. So by adding and removing the features and calculating the errors rate, then we can say these features are important, we have to consider, and those features which are by adding them the number of errors are increasing, so we have to remove those features. So let's see, and here I will show you some examples for them. So the important libraries here I have imported. So then we talked about types of supervised machine learning and types of supervised machine learning. Friends, we have two types. First type is called regression, and the second type is called classification. About classification we are going to talk in the next lecture. Here I am going to talk only about regression models. Regression models are used to predict continuous responses. This you have to remember. Now let's see linear regression models here. So it is a machine learning model or algorithm, we can say, that attempts to find the relationship between the features and response value, and that response value is continuous. See, response value is continuous. This you have to remember. So now we will attempt to find a linear relationship between our predictors and response values. Predictors means the features, the input, the data what we provide for the model, and the response value is nothing but the outcome or the output, we can say, or response variable or value, we can say. You have to remember. Now let's see here, friends. So in linear regression, friends, this is like we can show them in two dimensions like this. We have x-axis and we have y-axis, and this line is called the regression line. So from this regression line you can easily understand the relationship between the the features, whether the features has negative relationship or positive relationship, or there is not any relationship in between. For example, here see, by increasing the value of x, the value of y is also increasing, so that this is showing us there is a positive relationship between the two, or between the features. So this here, the distance from this point to this 0, so this is called y-intercept, and that is indicated through b naught or beta naught, we can say. So here this is called regression line, and this is the general formula, friends. We have independent, this is called dependent, y is dependent variable, and x1, x2, xn, these are called independent variables, and beta naught, beta 1, beta 2, beta n, these are called the coefficient of our independent variables here. Now here y is response value, the y is response value. So these should be calculated and the value will be stored on y. So y is called the response value, b naught is called the intercept, and this value from this point to this point, this value is called the b naught value, or we can say beta naught intercept. So b1 is the coefficient of x1, bn is the coefficient of xn. So now one thing you have to remember, friends, we are b naught, b1, bn, these are the population parameters. This is the general formula you have to remember for estimating the population parameter. But instead of this, we are using the samples. So by the samples, if you remember, we have something called estimate point. In estimate point, there we were using the sample, and through the sample we were predicting or estimating the population parameters, if you remember. Otherwise you have to refer the previous lectures. So here instead of that, we are considering some other forms here, like this simple linear regression. This is called the y is predicted value for y, for given x values, and b naught, you know, that is the intercept, and b1 is the slope, and the slope of the line here, and that is calculated, and we have to understand through the slope whether if the slope is like down from up down like this from here to this, so that is called negative relationship. If it is like bottom up, so that is called positive relationship. If it is like parallel line with x, so that is x, it means b1 is this one x is 0, so it means there is no relationship in between. Let's see, friends, how to calculate these constant values, for example b naught and b1, and then y predicted value. So b naught, it is very simple, friends. B naught is equal to the mean of y minus b1 and the mean of x. So if we have a series of numbers, response values, so we have to find the mean of y there, the mean of x there, and b1, so we can easily find the b naught value. So if we go to b1 again, we have to take the summation of xi, means the series of I minus mean of x. So we have to subtract them like that and add the result, and then multiply it with series of y minus mean of y. So all that will be added in the numerator. In the denominator again, we have x series minus y mean, x mean whole square, the summation of that. So that gives us b1. Now b naught, b1 we found, and put it in this formula. It will give you the predicted value for y naught, y. Now let's see here, for example, the examples are given here. If you remember this example, which we have already discussed, here we are taking some sleeping hours for the student, and also the marks what the student is getting, and if you remember, the relationship was negative, because if the person or the student is sleeping more, he or she will be getting less marks. If he is sleeping less, then he or she will be getting more marks. So this we have shown in the form of graph, if you remember here. So from this chart, you can easily understand that there is a negative relationship between the two variables. Here it is simple linear regression. You have to remember, friends, simple linear regression. In simple linear regression, we have only one independent variable. We have, but if we have multiple, so in multiple we have more than one independent variable. So here y is dependent variable and x is independent variable, so that is showing in this form of graph, and the relationship between them is negative, because you are seeing by sleeping more it is getting less marks, by sleeping less you are getting more marks. So it is shown in this form. Now let's go and calculate according to this formula, calculate b naught, b1, and then we predict the values whether it is right or wrong. Now what is our independent variable? The independent variable is x, so these are the values in the form of list, then y in the form of list we have provided the marks for them. So we have to find the mean for x and the mean for y. According to that, because we need them, here we have to put mean of x and mean of y. We need that for calculating the b1 value. So first I have to go in x value minus mean of x. For the whole range we have to apply that for the whole range, because here it is a summation. If you remember the summation, it means x series minus the mean for each and every x value. We have to subtract the mean and then we have to find the sum of all that. Here also y series minus mean of that, we have to then find the sum of that, the summation. So here again for y I have applied, this is y value minus mean of y for all the series, and then we have to calculate the denominator. In denominator, if you remember, x value minus mean of x, and that is whole squared for the whole range. Here is that, friends. Here x series minus mean whole square for the whole range we have to calculate, and sum is find the sum for that. So it is finding the sum, and that is stored in S3. So this is for y value in S2, this is x value, the whole series x minus mean, and that is stored in S1. Now if you want to calculate the numerator, so the numerator, how is that? We have to add them all, the summation of these two, x minus x mean, y minus y mean, the summation of this one, the summation of this one, it has to be multiplied and put in the numerator. So here we have to multiply. S1 is x series, x2 is y series, and we are multiplying these two for the whole range. So the whole range, here we have how many values? 4 values, so it goes up to 4. So it will be multiplied in the numerator, we got it. So after that, after multiplication, after multiplying these two, we have to sum them also. We have to find the summation of that. So that is why here I say b1 is equal to the summation of numerator divided by the summation of denominator. So this is the denominator, and this we have to find the sum of that. So this is giving us b1. And after finding b1, this is the formula for calculating b0. So we know the mean of y, mean of y, mean of x, and we found the value for b1. So you put all in this formula, so we can get the value of b0. So this is b0 and this is b1, all are calculated. I want to print the series, this series, x series, y series, and also the square root of y series, and then I want to print b0, b1 here, and then we are going to predict the values. Let's see, friends, here. So the first series is printed, second, third, and this one is showing us the b0 value, and b1 is equal to minus 11. So minus means here there is a negative relationship. If you remember, here we said if this b1 or b1 is positive, so it means it is a positive relationship. If this one is negative, it means a negative relationship. Like that, it shows it is a negative relation. Here also it is showing us a negative relationship, and after calculating the values, here also we got minus 11, means it is a negative relationship between the features, we can say. Or we can say the dependent and independent variables. Now let's predict here, friends. This is the formula. If you remember, y is equal to b0 plus b1 into x for predicting. This is one. So here I want to put the values and predict what the model predicts for the first time. So this is b0 value, we found it here. This is b0. And this one is plus b1, b1 is minus 11, so minus 11 I have put into x, this is x. So I say if the person is sleeping for 6 hours, the model predicts how much he will get. So it is giving us 93, but this value we gave, it was 95. There is some variation in between. So the model predicts 93 and we said it is 95. So now let's see if the person is sleeping for 7 hours, how much he will be getting? 82. If the person is sleeping, for example, for maybe like 8 hours, how much? 71. The model is predicting these values for us. I hope you understood this. Now let's see multiple linear regression. In multiple linear regression, we have more than one independent variables. Like here, let me execute this part, and you will see here, this is the salary of employees, and the salary of employee, friends, it depends on these features. So here we have more than one features. We have the rank, we have discipline, we have PhD, then we have service, then we have 6. So this salary is predicted, the system or the model has to predict the salary of person based on these features, which are called the predictors or input, or we can say the data, and this is called the response value. Now here I have explained, friends, these are the features and this is the response value. In this case, we can predict the salary like this: B0, B1 into rank plus B2 into discipline, like B3 into services, and based on these 3 features, because here we have more than one feature, like 1, 2, 3 features are there, so it is called multiple linear regression. But in previous example, if you remember, here we have only one feature, and that feature is nothing but the this one, x1, x sleeping hours. Now here, friends, let's see the dummy variables. The dummy variables, we say these are the variables for converting categorical data into quantitative ones, because we want to calculate the values, so we have to convert them in the form of numbers or quantitative values. So how do we do that? I have created a dictionary here, and I say you change the professor here. This is the feature. You take this feature and give it the rank. What is the rank I'm giving for that? It is 2. For assistant professor, it is 1, and for associate professor, for that we are giving 0. So then we are mapping them all, and that will be converted to numbers. From these values, it will be converted to 0, 1, 2, that's all. So also I want to convert the disciplines from AB to 0. From here we have 2 disciplines, one is B and another one is A, and that I'm going to convert to 0 and 1. And here we have, friends, like I want to convert the 6 also, for male 0 and for female 1. Let me execute one by one, and then we will see the result here. Yeah, now they are all converted to numbers, quantitative values. So here we have 2, 1 and 3, sorry 0. We have 0, 2, 1, and here we have 1 and 0, and here we have 0 and 1 and 6. Now let's see and find the relationship between them and show them in the form of graphs. Yeah, here it is showing us a relationship between rank in salary, discipline in salary, and PhD in salary. We have services in salary and 6 in salary, and this is called the regression line. So the points closer to the the regression line shows the close relationship, and the values which are spread out from this regression line, those are showing as the less relationship or weak relationship, we can say. So here these are the points in the form of regression line, we displayed them here. Now let's see and calculate the correlation between the points. Now I want to see the correlationship between salary and rank. Yeah, here, friends, salary here, this is called the diagonal. The diagonal is 1, 1. It means there is a positive relationship between salary and rank. So from here we can understand from the diagonal of the matrix. If you remember this, I have already explained in previous lectures. So here this is showing us there is a positive relationship between these two. It means salary and rank. So the value is returning, it is 0.5. It means 50%. We can say there is a positive relationship between these two features. Let me change this to some other feature like 6. See, here it is a negative relationship, so we can ignore this feature. We say no, 6 is not the feature that we have to take it as an input for the model, because there is a negative relationship. Instead of that, let us see the services. service. Yeah, in service also there is a positive relationship, friends, positive relationship, and here it is giving as it is 0.3. Yeah, this we can consider as a feature or a predictor. Now let's see another feature. If you remember, discipline is here, and discipline also it is a positive relationship. So this one shows that it is compared to the service, it is a weaker one. Compared to the rank, again it is a weaker one. It is it has less relationship, that much not close like rank. But the rank, if you remember, that was about 50% relationship, shows that. Okay friends, now let's see here. We are going to build a model, and for building the model we are using scikit-learn. This is a library we have to import here for machine learning. So this is important one I use here. Okay, scikit-learn, and from that I'm going to take the linear regression. I said linear model. From linear model you import linear regression. So in linear regression we need to first split the data. The data will be split into two parts. One is called the features and another one is called the response value, friends. These are the features and this is the response value. The response value, this is in the form of, this you have to remember, this is nothing but series, but this one is the data frame. You remember the difference between series and data frame. It is in the form of rows and columns, and it is a single list of values. So here this is called the features, the input values, and through these three input values like rank, service and discipline, you are going to predict the salary of employee. So it is multiple linear regression because we have more than one independent variables. 3 independent variables have, and we are going to predict the salary of employee based on these 3 independent variables. So this is x value, means the features, y value is a series of numbers, so that's salary, and that will be our response value. So here I'm going to split x and y into 4 types: x training value, x test, y test training, and y test. It will be converted. But you have to remember, friends, x values are nothing but data frames and y values are nothing but the series. So randomly it will be selecting the numbers from the list or the data set. And now then I have created here or instantiated the model by using regression model. I created the object here, and then after that I'm going to fit. I say okay, the object of this model, then fit, then we are giving the training data first to the model. After that we are going to test the model. So first we are going to train the model, we are going to train them. These are the features and these are the response values. Let me print them here and you will see the output here. Yeah, you see x training, it is nothing but a data frame because it has the values in the form of rows and columns. How many columns are there? 3 columns are there, and these are the values. But by default, how much? 75% will be selected as training data and 25% will be as a testing data. It will be selected. So here the second one, y value training, it is a list or a numpy array we can say. But here again, here x value, x test value, it is in the form of data frame. Y value, it is in the form of series. And now let's see, we want to find the coefficients and we want to find the intercept. So for finding the y-intercept, we have to use this attribute here, the object, linear object what we have created here. This is our object, and through that I am calling this attribute. I say intercept, and it is printing me y-intercept is equal to, okay, 72,787. It means this value is equal to that much. This value, this is called y-intercept. So the y-intercept we found, and that is equal to that much. Okay, now let's see the coefficients. These are the coefficients. B0, this is B1, and this is B3, the coefficients. Like the coefficients for rank is this much, the coefficient for service is this much, and the coefficient for discipline is this much. So it means if you are interpreting, if the rank is 1, so by default this is the value. If the service is 1, so this is by default the value. If this discipline is 1, so this is by default the value. Otherwise, if it is 2, so that 2 should be multiplied with this value. If it is 3, like this service is 3, so that 3 should be multiplied by that. If it is 1, so that will be considered as that value only. So these are the coefficients. So I have used a zip here. If you remember the zip, I zipped features with the coefficients, so it is showing me in this form also for better understanding. Now let's see and do some predictions, friends. Now let's see whether the model is predicting correctly or not. Okay, these are the features: rank, service, and discipline. And now I am providing here, I have to predict. So y predict is equal to, I use the model object here, and then I use the function predict, and I'm going to give these values for that. I say if the rank is 2 and the service is 40 years working experience and discipline is equal to 0, now it has to predict as the salary how much will be the salary for that person. Discipline was 0 and 1, if you remember, and services had a series of numbers, and rank B converted into numbers. 2 means professor, 1 means associate professor, and like that we use dummy variables here. So based on these features, the model is predicting as this will be the salary of person if the rank is 2, service is 40, and discipline is 0. So this will be the salary of person. You can change these values and see different values like that here. The model is predicting you different response values. Now then we talked about the regression model has some metrics that we have to calculate, friends. For calculating those values, so to compare actual values with predicted, we need to calculate the matrix. And we talked about it is not classification model, but it is regression model. We are not going to calculate the classification accuracy or model performance, but we are going to go and calculate the number of errors, and we have to minimize the number of errors by adding and removing the features, and that is called feature selection, which is helping us to select the features based on correlationship, like as we did here, friends. Here we have to see, so we see this is a good feature for the salary, and then service was a good feature. 6 was not a good feature because it was giving us very weak relationship it was showing us. So here we have to calculate this one, the mean absolute value. This is, we have to find the average, y minus the predicted value of y. We have to find the sum of that, absolute of that, and divided by number of observations, and that is showing us the mean absolute value or error. So it should be lesser than minimum. It should not be, if we are comparing 2 or 3 features, so it should be minimum in that feature we are going to select. If it is maximum, so we have to neglect that feature. So then we are going to calculate the mean square. Just we are squaring that. These are the features, we are squaring that, and then we find the summation and divide by number of observations, and root mean square. So just we are taking the square root of this one. Now let's see the example here. The same example I am taking. These are the true values for the sleeping hours, if you remember. These are sleeping hours in the first examples, friends. These are sleeping hours. So now by sleeping hours here, in these are the predicted values. These are the true values, and these are the predicted ones. How the predicted values are predicted? So 50, this one, let me predict the first value, how much it is. So we said it is 50 for 10 hours. Now let's see what the system predicts for us. The system predicts, or the model predicts, It is 49. The actual value is how much? Or the true value is 50, but the model predicts how much? 49. Let me give another like 8 hours. So for 8 hours we said 70, the actual value is 70, but the model predicts how much? 71. For 7 how much we are getting? Okay, 82. So these are predicted values and these are the actual values. So now let's go for 6 hours. For 6 hours we said it is 95, the actual value, but the predicted value is, by the model, it is 93. Now let me put these values here and calculate them. So 93, 82, 71, these are the predicted values and these are the true or actual values. Now if we want to calculate the mean absolute value, so what we have to do? We have to subtract from this value, from actual value, the predicted value, and then divide by number of observations. So 50 minus 49 is 1, 70 minus this one, it becomes 1. Absolute of that we are taking, if you remember, absolute we have to take, so that becomes minus 1, so that minus 1 is nothing but plus 1, absolute of that. 80 minus 82 minus 2, absolute of that is 2. So we have to add them all and divide them, so this will be the mean absolute error. And like that for each and every we have to calculate, and it is giving us these values. What is first I have to execute this one. Yeah, now let's see here, these are the values. So mean absolute error is 1.5, and square of that is equal, square of this one, square of that one is equal to 2.5, and root mean square of this value, it is giving us this one. So the minimum values are preferable, not the maximum. This you have to remember. How to calculate these values, how to compare the matrix. And mean absolute value or error is the simplest type of regression error. More understandable definition of this, it is more understandable because it is very simple, friends. We have just subtract them and add them and divide it by number of observations. That is what it is called more understandable and easy. The average difference just between the actual values and the difference values. And then we said mean squared error is nothing but the difference between true and predicted values used to use the most to minimize the larger values. So if we have larger values, instead of this one we will be using this one for easily interpreting them. And this one is used the most one, this one, root mean square error is used the most and easy to interpret them. Now what are these errors, friends, actually? So according to this chart, this is the regression and these are the data points. So the closer to the regression, it means the lesser the error, and the far from the regression, that is showing us the maximum errors. For example, if you consider this point and this point, so this point is closer to this regression line and it is lower than this regression. These are minus values and these are positive values. So far from the regression lines, it is nothing but maximum error, and this is called the minimum error. Closer, minimum, and far from the regression, that will be giving us the maximum errors. The last point, what we said, friends, we said regression matrix help us in feature selections. And how it is helping us? Very simple, friends. Just by adding and removing the features and calculating the errors by seeing the minimum error, those features will be selected, and those features which are giving us like more number of errors, so that will be neglected. So how many features? The same thing. These are the things what we already explained here. We have to give the features, and this is the response value, split them into training and testing, and then fit the model, and then predict it, and then we are going to print here the values here. Now here it is showing me this one. For how many features? 4 features. Now let me consider only this one, then you can understand. I take the copy and paste it here. Okay, I will reduce this one. I say no, 6 was not, remember, if you remember, it was not there. So the number, see here, it is reduced. The number of errors are reduced from the previous one, because the feature was, the relation between the feature was weak. and by removing that, the number of errors also reduced from that to this one. It was 400 and now it becomes 300 here. And now I'm going to reduce the service, and let's see whether it is the number of errors are reducing or not. Let me see. Yeah, it is reduced, friends. Here it is reduced. So like this, we have to compare these number of errors, whether it is reducing or increasing, and we have to select those features, and by increasing the number of errors or rate of error, we have to neglect those features. So I hope you understood about linear regression, multiple linear regression, and these were nothing but the types of supervised machine learning, and we will talk about this classification in later lectures. So we covered all these things. We talked about dummy variables, metrics of regressions matrix we talked, and then we talked about feature selection. I hope you understood, friends, this much.